oxygen at STP, that is standard temperature and pressure. Bond length as well as bond angle will be somewhat various. Hence it is known as non-linear as well as non-planar molecule. The hydrogen peroxide reacting with the oxygen and forming what? Water molecule with the liberation of oxygen. How many hydrogen atoms which is undergo ionization, that can be easily studied by using this heavy water. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called hydrogen. Under that, we have discussed about the hard and soft water, and we have learned that how does the water will become very hard due to the presence of calcium and magnesium ions. And also we have learned about the differences between the hard and soft water, and also we have learned about the types of hard water also. Those are temporary hard water and permanent hard water. Is it right? And also we have learned about the methods for removing the hardness of the water. So we have learned the different techniques, that is by boiling and also by using washing soda, by Clark's method. So there are plenty of methods will be there to remove the permanent hardness as well as the temporary hardness of the water. So today let us move on to the next topic of this unit about the preparation of hydrogen peroxide, and we are going to understand the storage of or store of hydrogen peroxide, structure of hydrogen peroxide, chemical property and uses of hydrogen peroxide. In addition to this, we are going to understand the heavy water, the structure and their uses, and hydrogen economy at the last. So firstly, I'll go with the hydrogen peroxide. So we all know that hydrogen peroxide is a liquid. It was first discovered by Tennant. Okay, let's see the preparation of hydrogen peroxide. Okay, in hydrogen peroxide can be easily prepared by the action of sulfuric acid or phosphoric acid or hydrated barium oxide. So here we are taking the hydrogen, we are taking H2SO4, that is sulfuric acid we are taking, or phosphoric acid we can take, which is allowed to react with what? Hydrated barium oxide. So you can see here, this is the formula for hydrated barium oxide, which is allowed to react with sulfuric acid. You know, it forms what? Barium combines with the sulfate and forms barium sulfate, and with the formation of H2O2. Why it is H2O2? You can see that there is a one hydrogen and two oxygen will be there and forms a H2O2 with the formation of water molecule. This is how by using barium oxide we can easily prepare the hydrogen peroxide. We have one more method, that is by hydrolysis of barium disulfide. You can see here the hydrolysis of barium sulfide, which is obtained by electrolytic oxidation of acidified sulfate solution at high current density, which yields the hydrogen peroxide. So here you can see that reaction, that is peroxo disulfate. So this is a peroxo disulfate, which is upon hydrolysis, it forms an intermediate product, which is upon further hydrolysis, you know, it forms what? HSO4 minus with the formation of H2O2, that is hydrogen peroxide. This is how by doing hydrolysis of peroxo disulfide. So peroxo disulfide, we can easily obtain the hydrogen peroxide. Next is we have few more methods to prepare the hydrogen peroxide. That is, this is a method which is used for laboratory preparation of deuterium oxide. So here you can see that K2H2O8, which is allowed to react with heavy water, which forms what? KdSO4 with the formation of deuterium oxide. Industrially, H2O2 is prepared by auto-oxidation of 2-methyl anthraquinols. You can see that 2-methyl anthraquinol, which is upon oxidation by using palladium as a catalyst, it forms what? H2O2 with a oxidized product. So here you can see that we can easily prepare the hydrogen peroxide by using what? Auto-oxidation of 2-alkyl anthraquinone. This is the one way, and we can easily prepare the industrially useful deuterium oxide in another hand. So hope you are understood with these two methods. In the one method we are preparing the deuterium oxide. In the second method we are preparing the hydrogen peroxide. Next is storage of hydrogen peroxide. It must be kept in wax-lined colored bottle because the rough glass surface causes its decomposition. The small amount of sulfuric acid, glycerol and acetanilide is generally added, which retard the decomposition of hydrogen peroxide. Otherwise, it is also known as negative catalyst. Okay. So, it should be always kept in glass bottle and it should be kept in dark condition. And remember, for this liquid, we add a phosphoric acid or glycerol, which is a negative catalyst, which does not increase the rate of decomposition. That is why we add those substances to the hydrogen peroxide while it is storing. Okay. Next is, we have a small calculation to understand how to prepare the 10 volumes of hydrogen peroxide, or we can say that how to calculate the strength of 10 volumes of hydrogen peroxide. Let's see now. Okay. So, calculate the strength of 10 volume solution of hydrogen peroxide. So, here the 10 volume solution of hydrogen peroxide means 1 liter of this hydrogen peroxide solution will give 10 liters of the oxygen at STP, that is standard temperature and pressure. So, hydrogen peroxide, we know that there are 2 hydrogen will be there, and we know that what is the oxidation state of the hydrogen? Is it right? It is 1. So, 2 into 1, it is 1, and we know that for the oxygen, atomic number will be 1. So, it will be multiplied with the 2. So, 2 into 1, it is 2. Similarly, for the oxygen, it is 16. It will be multiplied with the 2 because there are 2 oxygen atom will be there. 16 2s are 34. So, if you multiply 2 with the 34, you will get 68. Similarly, here, it develops what? Oxygen at what standard temperature and pressure? That is around 22.7 liters. It is around 22.7 liters and it is a standard value. On the basis of above equation, 22.7 liters of oxygen is produced from 68 grams of hydrogen peroxide at a STP, and 10 liters of oxygen at STP is produced from 68 into 10 divided by 22.7. How much you will get it? You will get 29.9. I'll consider nearly as a 30 gram. So this indicates that by using 10 volumes of hydrogen peroxide, it produces what? It produces 30 grams of oxygen. Therefore, the strength of H2O2 in 10 volumes of H2O2 will be easily equal to 30 gram, or you can say it is 3% of hydrogen peroxide. So, this is a small calculation you must know because those calculations are very important for your CET. That is why I have added this content here. Next, we will look into the structure of hydrogen peroxide. Okay. So, hydrogen peroxide is a non-linear, non-planar molecule. It has a open book shape structure and it has oxygen-oxygen linkage. Hence, it is also known as peroxyl linkage, and the structure will be goes like this. In a solid state, the peroxide linkage you can see between the 2 hydrogen atoms. So it is H2O2, right? So between this is a one hydrogen and one hydrogen. Between these two, you can see that the peroxide linkage will be there, and you can see that between the two oxygen atom, we have a bond angle around 94.8 and a bond length around 147.5 picometer, and you can see that the bond length of hydrogen and oxygen is around 95.0 picometer, and the bond angle between oxygen and hydrogen will be 111.5 degree. So in solid state, if it is comes, again you can see that there is a peroxide linkage will be there between two hydrogen atom, and the bond angle will be 101.9 and the bond length will be around 98.8 picometer, and you can see that the bond length of two oxygen atom is 145.8 picometer, and it has a bond length around 90.2. Compared to the solid state and in the gaseous state, you can see that their bond length as well as bond angle will be somewhat various. Hence, it is known as non-linear as well as non-planar molecule. Next is about the chemical properties of hydrogen peroxide. So, first I will go with the oxidizing nature of hydrogen peroxide. So, it is a powerful oxidizing agent and act as a oxidizing agent in neutral, acidic as well as in a alkaline medium. We have one more example for this. Hydrogen peroxide can oxidize the lead sulfide to the lead sulfate in acidic medium. You can see that this is a lead sulfate. When it is reacting with the water molecule, it forms what? Lead sulfate with the formation of water molecule. This reaction shows that the hydrogen peroxide, it acts like an oxidizing agent to the lead sulfate to become what? Lead sulfate. So, lead sulfide is become what? Lead sulfate. So, this indicates that hydrogen peroxide can easily act as strong oxidizing agent. Next is reducing nature. Hydrogen peroxide has a tendency to take up the oxygen from strong oxidizing agent. Thus, it acts as a reducing agent also. You can see that the hydrogen peroxide reacting with the oxygen and forming what? Water molecule with the liberation of oxygen. So, this shows that hydrogen peroxide is receiving one more electron and get reduced. Hence, it is known as reducing nature. Okay. So, we have one more reaction for that. Hydrogen peroxide can reduces the acidified paramanganate ion to the Mn2 plus ion. We can see that manganese oxide, which is allowed to react with hydrogen peroxide, which reduces the manganese oxide into Mn2 plus, where manganese oxide will be get reduces to Mn2 plus with the formation of water and oxygen. This shows that our hydrogen peroxide can also be act as very good reducing agent. Hydrogen peroxide can also reduce the iodine to iodide in the basic medium. You can see here iodine will be there, which is allowed to react with what? Hydrogen peroxide. In a basic medium, what will happen? This iodine is get converted into iodide ion, which is iodide ion with the formation of water and oxygen. This shows that our hydrogen peroxide can act as a reducing agent in the basic medium also. So, now we have understood the oxidizing and reducing nature of hydrogen peroxide. Next is uses of hydrogen peroxide. Hydrogen peroxide will be widely used in different cases. In bleaching of delicate articles like wool, hair, as well as with the feathers and ivory, we use this hydrogen peroxide. For restoring the color of old lead paintings whose white lead has blackened due to the formation of lead sulfide by H2S of atmosphere, the hydrogen peroxide can cover the black lead sulfate to white lead sulfate. So, in order to protect or restore the color of old lead paintings also, we use a hydrogen peroxide. And in aerating agent, in the production of sponge rubber also we use the hydrogen peroxide. And not only this, you would have familiar with the antiseptic nature and germicide nature of the hydrogen peroxide. If somebody has got an accident, suddenly they'll apply this hydrogen peroxide on the wound, because if you apply the hydrogen peroxide on the wound, you would have seen that the formation of oxygen gas which will be in the form of hissing noise. Have you all observed? Yes. So this indicates that our hydrogen peroxide is itself is an antiseptic agent and germicide for washing the wounds and teeth, ears under the name of perhydrol. In the manufacturing of sodium perborate and sodium percarbonate are also used in high quantity detergents. So these are the some of the main uses of hydrogen peroxide. We'll discuss with another few. And it is also used as anti-collar and oxidant for the rocket fuel. So in the rocket fuel, it will be used as oxidizing agent, and in the detection of titanium, vanadium and chromium ion, which forms the peroxides of characteristic color, and in the production of epoxide and polypropylene oxide and polyurethanes also, in that production also we use what? Hydrogen peroxide. And not only this, we also use this hydrogen peroxide in the synthesis of hydroquinone pharmaceuticals and in food products like turmeric acids, and in the pollution control also we use the hydrogen peroxide, especially with the domestic effluents where it restores with the aerobic conditions of sewage wastages, for the pollution control of industrial effluents which are containing cyanide ions and hydrogen peroxide, which oxidizes the cyanide ions to the harmless product. This is how, in order to treat the sewage effluents as well as the industrial effluents, we add the hydrogen peroxide, because this hydrogen peroxide, which it oxidizes the cyanide ions, which causes a more effects to the effluents. That is why, in order to oxidize this into the simple form, we use a hydrogen peroxide. Now let us see what is heavy water. So heavy water, which is nothing but a normal water which is get electrolyzed and become a heavy water, and it has a formula of D2O. This is a common representation of heavy water. Heavy water is prepared either by prolongated electrolysis or by fractional distillation of ordinary water as a byproduct, and it is also used in some of the fertilizer industry. Okay, let's see the uses of heavy water now. It is extensively used in moderator, in nuclear reactor, and in the exchange reaction for the study of reaction mechanism. And for the preparation of deuterium, the heavy water will be used. Okay, the heavy water which produces a deuterium, upon hydrolysis, it decomposition with the metals, because of its nature, for the production of or for the preparation of deuterium also we use the heavy water. Okay, so heavy water which is also used in tracer compound for studying the various reaction mechanism, and it also been used for studying the structure of some of the oxo acids of phosphorus, such as you can see that the H3PO2 and H3PO3 are the oxo acids of phosphorus to determine the number of ionizable hydrogen atom. So how many hydrogen atom which is undergo ionization, that can be easily studied by using this heavy water. You can see this heavy water which is also used in preparation of some of the deuterium compound. You can see here the calcium carbide reacting with deuterium oxide and forming C2D2 with the formation of calcium OD2. Similarly, the SO3 which is allowed to react with deuterium oxide and forms what? D2SO4. Similarly, aluminum carbide reacting with deuterium oxide and forming what? CD4 with the formation of aluminium OD. Next is hydrogen economy. So what is the hydrogen economy? Which is nothing but a hydrogen we are using as a fuel. Okay. The electricity cannot be stored to run the automobiles. Hence, it is not possible to store and to transport the nuclear energy. Hydrogen is an alternative source of energy. Hence, it is known as hydrogen economy, and hydrogen has a following advantages. Already we are very much familiar that by using electrical vehicles. Is it right? So, you would have observed that for the electrical vehicles, we need to charge it many times. Is it right? So, once we use, the charges will become very less. That is why we cannot restore the charges for the longer time. We need to keep it charges for regularly. That is why, and also transfer of nuclear energy will not be possible very easily. In such situation, we can use the hydrogen as another alternative sources of energy because it has a following advantages. That is mainly because it is available in the abundance nature in the combined form of water, and combustion, it produces what? Water molecule. Hence, it is pollution free. And the hydrogen peroxide fuel cell will give a more power and excellent reducing agent, and it will be used as a substitute of carbon in the reduction process in industry. This is how we can easily understand why the hydrogen will be used as one of the main sources of energy, which is an alternative source of energy when it is compared with the electrical energy. Next, we also have some of the obstruction or obstacle we can say in using a hydrogen because of the thing is transportation. Is it right? Hydrogen gas is explosive, hence it is very difficult to store and transport, and the formation of hydrogen from the H2O, it is very difficult. So, in order to produce this hydrogen from the water molecule, it is a long processes. That is why this production as well as the transport, it become a difficult for the industries, and cheaper production of hydrogen is a basic requirement of hydrogen economy, which is not possible now. And the main aim and advantage of hydrogen economy is to transmit the energy from the core of hydrogen. So, it is very difficult to transport the hydrogen, as well as it is not very easy to prepare the hydrogen from the water molecule. These are the obstacles with the hydrogen gas. It will be used as a fuel. So, by this, I like to say that I have covered with this small unit with the 5 session. What are all the things which I covered in this session? It is very important for the examination point of view. Have a look on it and try to work out. We'll meet you with the next session. Till that, take care, be safe. Thank you.